Hello, good morning, all of you. I hope all of you are safe and sound at your home. So, my dear friends, we are discussing the analytical chemistry paper number CSA 393, that is CBOP part B, and the title of our section is analysis of food. In this we have started the fifth chapter, that is analysis of lipids. Okay, and in this lipid analysis or fat analysis we have discussed the what is meant by lipids, what are the methods of lipid determination or fat determination that we are discussing. Okay, today our topic is total fat analysis by gas chromatography for nutritional labeling. I already told you that food products are, when we are marketing them for consumer, then on the packaging material the nutritional value must be printed. So by consuming that particular amount of that food material, what amount of energy, carbohydrates, proteins, fats that we are getting, this information is necessary, and that's why this information, that is a fat analysis, is done by gas chromatography using this total fat content by this gas chromatography technique. So in this, the principle of this method is that generally fat and fatty acids are extracted. Fat and fatty acids are extracted by doing hydrolysis. This hydrolysis may be acid hydrolysis or alkaline hydrolysis, etc. Different types of hydrolysis can be done for this fat analysis. Prior to GC analysis, before going to GC analysis, this fat analysis is done. Okay, and in this analysis pyrogallic acid is added. Pyrogallic acid is added. What is the function of this pyrogallic acid? It reduces or minimizes the oxidative degradation of the fat. It minimizes the oxidative degradation of the fat. So that's why this addition of this pyrogallic acid is essential. Then the internal standard material is used in this case, and the name of that internal standard is triundecanoin, and this is one of the triglyceride. Okay, triglyceride is there, and this is the internal standard in this GC analysis. So in relation to that, this internal standard, the other retention times, of other fats and fatty acids can be determined in gas chromatography. Okay, then this fat is extracted in ether. We are going to see the procedure in detail, but this is the principle. The fat is extracted in ether solvent, and then it is methylated by using a boron trifluoride methanol mixture. Boron trifluoride, that is BF3 methanol mixture is there, and this reagent is used to convert that fats and fatty acids into FAME. FAME. So what is this FAME? This FAME is fatty acid methyl esters. Fatty acid methyl esters. Okay. So this FAME, once we are getting this FAME, and this FAME are estimated, they are determined by using GC, that is gas chromatography. Okay. And whatever the concentration of, whatever the percentage of that FAME that is producing, that we are determining in GC, it is equivalent to the fat content or fatty acids content in that food sample. Okay, so this is the principle of this total fat content by GC. Now the procedure. There is a standard sample preparation procedure is given. Standard sample preparation procedure is given according to AO, according to that standard specifications given by that organizations in USA. Okay, this standard sample preparation procedure that we have to see. So what is this procedure? first of all, weigh accurately either 0.1 to 0.2 gram of that sample, 0.1 or 0.2 gram of that sample in a round bottom flask, in a round bottom flask. Okay, so assembly is set up accordingly. So this much amount of the sample is taken in round bottom flask. Then if the sample is in liquid state, then you can use hexane as a solvent and dissolve that fat content or that fat which is extracted or which is obtained by the hydrolysis. Okay, then dissolve it in hexane, then transfer it in a round bottom flask. Then in that round bottom flask add NaOH and methanol. Add NaOH and methanol. Then this mixture containing NaOH, methanol and this sample is, along with that we have to add some porcelain pieces or boiling chips. We call it as a boiling chips. Boiling chips are added because we are going to do reflux here. Okay, we are going to boil that mixture along with that ether solvent. This mixture is get heated, so that's why boiling chips are get added, and then water condenser is set up. Water condenser is set up. So this is a round bottom flask. Okay, and a water condenser is get set up. Okay, this is the inlet, this is the outlet. Okay, so this is the heating system, this is the assembly, and we can use the laboratory stand to clamp this round bottom flask as well as this condenser. Okay, and in this round bottom flask what we have taken, our sample is taken, sodium hydroxide, then methanol is solvent is taken, and some boiling chips are used here. Okay, such as porcelain pieces. Then reflux this mixture for about this mixture for about 15 minutes. Reflux this mixture for about 15 minutes. Then after this add your BF3 methanol mixture. Okay, so this is a methylating reagent. BF3 methanol reagent is there, and this reagent is get added in this, and then reflux this mixture for 5 minutes. Okay, after that add heptane about 10 to 15 ml, and then again reflux for 1 minute. Reflux for 1 to 2 minutes. So this is the procedure, standard procedure given by this organization. And after that, after this reflection, you have to take this round bottom flask along with that condenser, which is away from this heating assembly. Okay, whatever it may be, whether it is steam bath or water bath or oil bath, etc. Okay, so remove that and allow it to stand as it is. Don't disturb it. Then after getting the room temperature, when this assembly is getting room temperature, then simply add saturated solution of sodium chloride. We call it as a brine solution. So brine is get added, and when we are adding brine, there is suspension which is get formed between this heptane, this water, that is methanol water, and this organic solvent, non-polar organic solvent heptane. Suspension may be formed, and this suspension is broken by this saturated solution of sodium chloride, that is brine solution. Okay, and when this suspension is broken, the heptane layer has a low dense, so it will float at the top layer in this round bottom flask. Okay, then take a sample cuvette or just like a test tube, okay, and take a scoop of or a pinch of sodium sulfate. Sodium sulfate is a dehydrating agent. Okay, so if we are decanting that heptane layer which is formed in this case, okay, after distillation, after refluxing, the heptane layer can be decanted, okay, and if some moisture is present in that heptane layer, that can be adsorbed by using sodium sulfate. Sodium sulfate is a white chalk like or just like rangoli powder, okay, calcium carbonate powder, just like that. And when we are having a cuvette or test tube like material, okay, and we are pouring that heptane layer into that cuvette, okay, so take some scoop of or a pinch of sodium sulfate in that, so that your heptane layer will be free of moisture, free of water. Okay, so this will be the extract that you made by using this procedure. Okay, then after that, decant that heptane layer, allow it to evaporate at room temperature, okay, and then at high temperature. Okay, this is the procedure for which is called as standard sample preparation procedure for the this is sample preparation method for the total fat by GC, that is gas chromatography. Okay, then add a specific amount of that material which is prepared by this sample preparation method into the GC column, and then that GC system, gas chromatography system, will give you the particular analysis of that fat. This is giving in detail the detailed analysis of that fat. Okay, so that's why this is necessary for the nutritional labeling on the food products packaging. Now GC conditions are there, not necessary to remember and not necessary to GC, how the GC parameters are used, what is the temperature of that column, how it is changing, variable, okay, which column is changing that we are using, all these that are not necessary. Okay, then the next point is calculation part. So what is the calculation? How that fat content, total fat content is calculated? It is calculated by using this formula: percent fatty acid on lipid basis is equal to milligram of lipids divided by milligram of fatty acids divided by 100 into 100. Okay, so by using this formula we can calculate the percent fatty acids. Okay, so this is the these are the methods that we have seen, and they are called as solvent wet extraction techniques. Now our next point is non-solvent wet extraction methods. Non-solvent, here we are doing extraction, but here we are not using any solvent. Okay, so that's why non-solvent wet extraction methods for the extraction of fats from the food sample. So the first one is Babcock method for milk fat. Babcock method. So what is the Babcock instrument is there, or Babcock apparatus is there? It is just like this. Babcock apparatus is like this. It is just like our volumetric flask or a standard flask, but this neck is having a marking. Okay, so we can measure the volume of that solution which is kept in that Babcock apparatus by reading this marking present on this neck of the apparatus. Okay, so Babcock method for milk fat. This method is particularly used for the analysis of fat present in the milk sample. Okay, so this is special method for milk fat. So now what is this method? In this case we are using here sulfuric acid. In this case we are using here sulfuric acid. We are using here sulfuric acid, and this sulfuric acid is used to digest proteins. Sulfuric acid is used to digest proteins. Okay, so when proteins are digested, heat is released, and fats get solubilized. Okay, so whatever the fat present in that milk sample is get solubilized and it is converted into a liquid fat. Okay, and when this liquid fat is generated or it is converted, then add heptane. Okay, then some hot water is added. Okay, some hot water is added, and then this hot water is increasing the volume of this material or solution which is taken in this Babcock apparatus. Okay, and then this whatever the volume which is in this neck region, okay, that can be measured by using this markings or scale which is present on this neck region of this Babcock apparatus. Okay, so this is the Babcock method for milk fat. Then the next one is Gerber method or Gerber method for milk fat. This method is also similar to that of the Babcock method. The only difference is that along with that sulfuric acid, in this case we are using here sulfuric acid plus amyl alcohol. Sulfuric acid plus amyl alcohol. Okay, so this is the only change between these two methods. Amyl alcohol is used in Gerber method. Okay, this is also one of the best method for the analysis of fat present in the milk and milk products, dairy products. Okay, then Gerber flask is there. Here we are using here Babcock flask or Babcock apparatus. In this case we are using a Gerber pipette and Gerber flask is there. Okay, and whole procedure is same, but only the difference is along with that sulfuric acid, amyl alcohol is also used in this case. Okay, so these are non-solvent weight extraction methods. Now the last topic from our chapter is the instrumental methods. Okay, now what are these instrumental methods? Means by using instruments we can determine the amount of fat present in the food sample. Okay, so these are non-destructive techniques. Instrumental methods are non-destructive techniques. What is my non-destructive techniques? Non-destructive techniques means the food sample is not degraded in this case. Okay, and hence they are called as non-destructive techniques. Now among these the first one is IR method. So what is this IR method? IR stands for infrared method. We know that IR spectroscopy is used to get the information about what are the functional groups present in our molecules or compounds. That information is get by the IR spectroscopy. Here at particular wavelength of 5.73 micrometer, at this wavelength the IR radiations are get absorbed by the fat. IR radiations are get absorbed. IR radiations are get absorbed by the fat. Okay, and this IR absorption is directly proportional to percentage of fat or fatty acids present in the sample. Percentage of fat or fatty acids present in the sample. Okay, so that's a higher the IR absorption, more amount of fatty acids are present in the sample. Lower the IR absorption, less number of fatty acids are present in the sample. Okay, so this could be useful for the direct analysis by using instruments such as IR. And the next one is specific gravity method. Specific gravity method is having a name, having a title, Fauchelet method. Okay, so what is specific gravity method? We know that mass per unit volume of a particular substance is known as its specific gravity. Okay, so this property of that material, okay, is used to determine the specific gravity. So this specific gravity method is related or it is associated by the use of a sophisticated software. A computer operated system is there, and this will give you a direct readout. Direct readout means a display is there, and that display in that instrument displays directly what is the specific gravity of that particular sample, and by using that specific gravity we can determine the amount of fat present in the sample. And the third method is known as nuclear magnetic resonance. Okay, so this nuclear magnetic resonance NMR technique is not a widely used technique for this fat analysis, but in recent days in some Europe and America, such countries, they are using this NMR technique for the fat analysis of the food samples in their countries. Okay, so the details are not given in our text. Okay, but this is only the general information given for us, that NMR spectroscopy NMR method can be used for the fat analysis in the food samples. Okay, so these are the three instrumental methods: IR, NMR, and specific gravity. Okay, the specific gravity method has name postulate method. So as your examination is online, that is based on multiple choice questions, so such questions can be asked in your examination. So what is the lambda value for this IR method used in fat analysis? So such things can be, you have to remember, that is lambda is equal to 5.73 micrometer. Okay, so such things can be asked. So do thorough study for this. You have to read and watch carefully these videos. Okay, so I think this is sufficient for today, and this is the end of our half portion. Okay, because analysis of lipids, this chapter is having two parts, that is part A and part B. Analysis of lipids part A is consisting of, or it is related to the fat analysis, and part B is related to the characterization of lipids or characterization of fats. Okay, so this half portion, that is A portion, is over. Then tomorrow onwards we will see the B portion, or the remaining part, that is characterization of fats. Okay, thank you very much for watching this video. Have a nice day.